In the upcoming segments, I'm going to provide a couple of examples of Simpson's paradox. This is also known as reversal paradox, and in the realm of regression, it is known as net suppression. Simpson's paradox can make results look confusing because we have some hidden variable in the data that is causing us to make misleading inferences about what is going on. And so I want to provide a couple examples of this so that we can be alerted to this when it's going on in our data. So here we have a situation where we're going to imagine that we are the dean of the School of Psychology at a university, and we have two graduate programs. We have a clinical psych and an experimental psych program. And imagine that we are being investigated for gender discrimination in our selection methods for these two programs. So here we have some data to work with. We have the program's acceptance rates broken down by gender and program. And so for the clinical psych program, we have the female selection rate is given. It's 15 who were accepted versus 100 who applied. So that is a 15% acceptance rate for females. For males, on the other hand, we have 1 who applied out of 10, who was accepted. We have 1 who got in, and a total of 10 who applied. So this is an acceptance rate of 10%. Now here it appears that there's a slight bias against males in that program. For experimental psych, we see a similar trend. So for females, we have 6 who got into that program out of 10 total who applied for a percentage of 60. And for males, we have 50 who got in, and we have 100 total who applied. So that selection rate is about half. 50% of men got in who applied. And so here again, it looks like a slight discrimination against the men. However, if we look at the gender totals, that is the last row of this table, across programs, so we have a total of 21 females who got into one of those programs, that's 15 plus 6, out of a total of 110 ladies who applied to both programs. For males, we have 51, we have 1 plus 50, who were accepted into either program, out of 110 who applied in total, and this is a percentage of 46. So we have 19% selection rate for ladies, and we have 46% for the gentlemen. And so that looks like there's a discrimination against the females. So this is called the reversal paradox because we can see that even though within program it looks like males are the ones who are discriminated against in the selection process, when we look across the program, this reverses. And so if we were the dean of the School of Psychology, how would we resolve this issue and really understand if there's any discrimination that is occurring? Well, the secret lies in understanding the selection rate for each program. So let's look at that. For the clinical psychology program, it looks like 110 applied, but only 16 got in. We have 15 females and 1 male. And so that's less than 15% acceptance rate, so that's really a competitive program to get into, very difficult. For experimental psychology, it looks like it's easier to get in because we have 56 individuals who were accepted, 6 female and 50 male, and that's out of a total of 110 total applicants. And so that is a much better chance of getting in, about a 50% chance. And so the issue comes into play because females and males made different choices about which program to apply to. So it looks as if females disproportionately apply to the more difficult program. They chose the harder one to get into, which was clinical. And for males, this was reversed. So they decided to apply to the one that was easier to get into. They were just more interested in that line of work. And so they applied to the experimental psych program much more than the clinical, as you can see, 50 versus 1. And so what we have is we have an entanglement with gender and the program to which they decided to apply. And that is what's causing this reversal. So we have an unaccounted for variable in our model, and we can't make a good decision about discrimination until we control for that variable, and that is competitiveness of the program. So if we look at women's overall acceptance rates, the 19% in the total by genders row, this is going to be biased downward because most of the women are applying again to the more difficult program. And what this is doing is weighting the results in a way in which the clinical program acceptance rate for women has this unduly large influence over the overall selection rate, the 19%. So this is biased downward. For men, it's the opposite. So for males, their overall acceptance rates across the two programs, that 46%, is biased upward because most of them are applying to the easier program to get into. And this is weighting their results or their overall selection rate in such a way that their experimental psych acceptance rate is having this unduly large influence over the overall selection rate for men across the two programs. So really what we have going on is we have women's overall selection rate is biased downward, men's is biased upward, and so we need to fix that. And the way we fix that is to equalize basically this variable of competitiveness of the program so that it's not having this undue influence over the final result. And the way we do that is we just take the average percentage for both males and females. So for males, we have 15% in one program, 60 in the other. We're going to add those together and divide by 2 because there are two programs, and then we have this result that takes away the undue influence of the fact that more females were applying to the harder program, and we get basically the end result is that we have controlled for the competitiveness of the program and held that constant. So when we do that math, we get 37.5%, and please note that all of these numbers with explanations are provided in the notes at the bottom of this slide, so you can check them out at your leisure. For males, we're going to do the same thing. We're going to do a 10% plus 50%, and then we're going to divide by 2 for the two programs, and that gives us a total of 30% as a selection rate for males. So yeah, in this case, we have females have an acceptance rate of 37.5% and males 30%. So it looks like a slight bias against males, which makes sense because when we looked within program, that's what we saw as well. So we can trust this result. Notice that there is still a gap, but it is way less of a gap than the totals by gender row would indicate. And it's also reversed such that it's not females who are being discriminated against in a large way, 19% versus 46%, but it's really the males who are being accepted less, 37.5% for females, and then for males, 30%. So this paradox can be a bit complex, so take some time to think it over and look at the numbers and see what's going on with them and understand it on a deep level, because this basic issue is one of the issues that we see a lot of times with regression and just with aggregating data in general in this fashion. For IO students, I just want to give you a quick preview of selection coming up. When you're working in the field of selection and we're trying to select employees for certain positions in a fair and legal way, we run across this issue all the time, and I've talked to practitioners in the field dealing with this. And basically what happens is you have certain positions, and some of them are easier to obtain than others. The selection rates vary, and so some jobs are very competitive and others are less competitive. And typically we have groups that we're trying to be fair to, so we have gender and ethnicity, and we want to make sure that we are selecting the best people for the job regardless of their gender or ethnicity. But the problem comes into play, as it does here, when we have more females applying for the more competitive or less competitive jobs than males. And when we have that situation going on, then we can see this reversal paradox occurring. And so if we have a very competitive job, but only whites are applying for it for the most part, and then minorities are applying for the job that is a little bit easier to obtain, we often see this in practice, then it can cause conflicting results when we look within that position versus across the position, as we see here. So instead of program, we have job position. And we will see that sometimes, depending on the way we're aggregating the data and looking at it, it can appear that we're discriminating against men, when in reality we're discriminating against women more. And so this is just helpful to keep in mind for that purpose. I will be showing another example of this paradox at work in the next segment.